Alright, today we're going to talk about polygons and quadrilaterals. So we have a ton of vocabulary words there, so let's just talk through those very quickly. The first one is a polygon. So a polygon means a closed plane figure whose sides are segments that intersect only at their endpoints. So, for instance, what that means is you can't have a triangle, or kind of looks like a triangle, and it doesn't connect. So it has to be closed, okay? So no open sides, and that they intersect only at their endpoints. So, for instance, if I had something that looked like this, there is an intersection right here, which is not an endpoint, so this would not be a polygon either. A regular polygon is where all sides have the same length and all the angles have the same measure, so an easy one for that one would be a square. Convex, these are the two that are kind of easy to get confused. If we have a convex polygon, it means a segment joining any two interior points lies completely within the polygon. Concave, if a segment joining any two interior points does not lie completely within the polygon. Those will probably be easier whenever we actually look at an example, so don't stress too much about those just yet. For a trapezoid, it's a quadrilateral with exactly one pair of parallel sides. Remember, whenever we talk about parallel, there are two lines that will never intersect. A parallelogram is a quadrilateral with both pairs of opposite sides parallel, so it's going to have four sides, and you'll have two sides that are parallel to each other, and the other two sides will be parallel to each other. Then you have a rhombus, which is a parallelogram with four congruent sides. And then you have a diagonal of a polygon, which is a segment that joins two vertices. It's supposed to be TWO, two vertices that are not adjacent. Okay, now first, for these two images, we want to tell whether the figure is a polygon. So remember, the criteria for it to be a polygon is it has to be closed, and the sides only intersect at their endpoints. Okay, so nothing that looks kind of like that hourglass figure up there. So if we look at this first one, so we want to, if it is a polygon, we want to classify it and tell whether it's convex or concave. So first, if we look at this figure here, it is closed because it does have all of these, none of them are open, they all connect. Everywhere where the sides intersect are only at endpoints, so we're good there. So yes, this is a polygon. If it is a polygon, we should be able to classify it. Now, how we classify polygons is by how many sides they have. So if I count the number of sides in this polygon, I have 1, 2, 3, 4, 5. So a 5-sided polygon, hopefully you remember this, is called a pentagon. Now, to tell whether it's convex or concave, if we look back at those vocabulary words, it said a convex polygon means it's a segment joining any two interior points lie completely within the polygon. If I can put 2 points inside this polygon and the whole segment is within the polygon, it is a convex polygon. So, for instance, if anywhere in this polygon, it doesn't matter where I draw these 2 points, that line is always going to stay in the polygon. If there's even one place where I can draw 2 points and it's going to leave the polygon, it's going to be a concave. Now this one, since no matter where I draw these two lines, or wherever I draw those 2 points, that line's going to stay in the polygon. So this is going to be a convex polygon. Okay. Now, let's look at this kind of plus sign looking thing. So first of all, let's decide if it's a polygon. So if we ask ourselves, is it closed? Well, yes it is, because all of these endpoints here, they're not open, it's all closed. And then where all the sides intersect, they are all at endpoints. So yes, this is a polygon. We should be able to classify it, so let's count its sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You may know this, you may not. You can either call it a 12-agon, or a 12-sided figure is actually called a dodecagon. If you're not sure what it is, just go with the number. So a 12-agon and 11-agon, just whatever that number is where you'll put that. Okay, so now we want to be able to tell whether it's convex or concave. So remember, I'm going to draw 2 points and see if that line leaves the polygon. So right there I'm good, but if I draw a point here and a point here, Look at that. See how the line exits the polygon? Just because it does that in one spot there, it means it is a concave polygon. And how I kind of remember these is if you kind of look here, these are like little caves, right? And if I draw 2 points on either side of this cave, my line is going to leave my polygon. So this is a concave polygon. Alright, now finally we want to find the value of x, so kind of similar to what we did in yesterday's lesson. Yesterday we were talking about finding the value of x if my figure was a triangle. Now this time they're a quadrilateral, so a four-sided figure. Now all four-sided figures, so all quadrilaterals, the sum of their angles is, and let's think about this, we know a lot of quadrilaterals, we have squares, we have rectangles. Hopefully you can kind of think about it, and if a square, their interior angles adds up to 360, it's going to actually work that way for all quadrilaterals. So the sum of all the angles in any quadrilateral is going to be 360. So what we're going to do, just like we did yesterday, for this first one, we're going to take all of the sides. So not 150, we're going to take 105 plus 6x plus 11 plus 5x plus, and remember, that little symbol right there means it is a 90-degree angle. So if I add up all the sides, I know it is equal to 360. Okay, well now I have a bunch of like terms that I can combine. So I have 6x plus 5x, which gives me 11x. And then I have 105 plus 11 plus 90, which gives me 206, and that is equal to 360. Subtract 206 from both sides. 11x equals 154, and if I divide by 11, x equals 14. Okay, so I want you guys to do this next one. So I want you to add up all the sides that equal to 360. So pause the video, work out that problem for me. Alright, hopefully you ended up with x equals 56. If not, go ahead and check out your work, see where yours varies from mine.